Welcome to section 4.6, dividing polynomials. Alright, so example 1, we have do as indicated. So basically, we're just going to be dividing polynomials, and it's a lot like if we did long division. So if you recall, when you're doing something like long division, so 1 maybe 142, what do you do? Well, we ask ourselves, does 2 go into 1? We'll say no. And then we'll say, does 2 go into 14? And we can say yes, 2 goes into 14. So we'll say how many times? Well, 2 times 7 goes into 14, right? And then after that, we'll do the subtraction. So 2 times 7 is going to be 14. Subtract, that's a 0. But we're not done, remember? We have to bring down the next term, which is a 2. And then we ask ourselves again, can 2 go into 2? We'll say, yes, it does. How many times? 1. And then we'll do that subtraction, multiply the 2 times the 1, and we get 2. And we subtract, and we're done. So this cycle of checking what we need to multiply by to get the term, and then doing the subtraction, and bringing down the new item, this same concept is what we're going to do with division of polynomials. It's very, very simple. So let's take a look at what we have here for A. We have 15x squared plus 3 minus 12x divided by 3. So we're going to go ahead and set this up for long division. But when we do that, we have to be careful. We want the item inside the house, I'll call it, to be in descending power. Currently, it's not. So we'll fix that. We have 15x squared, and then we'll rewrite the 12x first, and then the 3, because remember, we want it in descending powers. So now it's all set up, and we're going to ask ourselves, how many times can 3 go into 15x squared? Well, 3 times 5 gives me 15, and then I need to get that x squared, right? So we know that 3 times 5x squared would give me 15x. So let's go ahead and do that subtraction. Let me bring down the subtract. I'll use yellow. So 3 times 5x squared is going to be that 15x squared. And then 15x squared minus 15x squared, they cancel out, and we're left with 0. But we're not done. We still have these other terms we need to work with. So let's go ahead and bring down the 12x. And we have a new cycle. As just like with the long division with normal numbers, you have the cycle. Multiply and then subtract. So now we're asking ourselves, how many times can 3 go into 12x? Well, oh, and careful, it's a negative 12x. We need to keep that in mind. 3 can go into negative 12x how many times? Negative 4x times. Okay, so we'll go ahead and do that subtraction. So 3 times negative 4x is going to be that negative 12x I'm looking for, and they cancel out. Negative 12x minus negative 12 cancels, and we have 0. But remember, we're not done yet. We still have that 3 right here. So we'll go ahead and bring down that 3. And our last time we ask ourselves, can 3 go into 3? The answer is yes. How many times? 1. So we'll do plus 1. And then we do the subtraction for the last part of the cycle. 3 times 1 will give me that 3. Subtracting, that's gone, and we have a remainder of 0. Alrighty, and that is it. So our answer would be 5x squared minus 4x plus 1. Now, if we had some remainder, let's say, for example, we had a remainder of 2, what we would do is we would do plus 2, and we would divide it by the divisor, 3. Okay, that would be if we had a remainder. So, if I wanted to be odd, I could go ahead and rewrite this with a remainder. I could go ahead and write it with 0 over 3. So that would be if I was writing it in remainder form. But because there isn't a remainder, we had 0, we usually don't put that, and then that trinomial right there, 5x squared minus 4x plus 1, would be my answer. And I'll go ahead and box that. So as you can see, we have the cycles, we do the multiplying, very similar to long division. So let's take a look at B. We have 3k squared plus 9k minus 14 divided by k minus 2. What's the main difference between B and A? Well, the main difference here is the divisor was 1 term, whereas now our divisor is 2 terms. So that makes the difficulty a teeny bit higher, but not too bad. And let's see, so you have 3k squared plus, 3k cubed plus, there's no squared term here. So since there's no square term, I'm going to add a placeholder. We don't have any k squareds, so I'll do 0k squared. And then we do plus 9k minus 14. So notice that placeholder there does help out when you're multiplying. So make sure to check that everything is in descending powers. And actually, I'm going to go ahead and rewrite that 3 to be an actual cube. So now, the main difference here is that we have a binomial going on. But we're still just going to focus on the first term. We're not actually going to focus on the x minus 2. We're going to focus on the first term and ask ourselves, how many times can that first term go into 3k cubed? Well, k, if I multiply k by 3k squared, if I multiply those two together, so k times 3k squared, I'll get 3k cubed. All right, so let's go ahead and do that. We'll set up my subtraction. Now this is where the part is different than part A. We're going to be multiplying 3k squared to this binomial, which means we'll get the 3k cubed, but we also have to remember to multiply the 3k squared to the negative 2. So that'll be negative 6k squared. So that's what's odd about this. We're going to focus on the k to figure out what to multiply by, but because it's a binomial, we still need to remember to multiply that negative 2. Okay, let me go ahead and erase this because it's a little more confusing. Oops, I accidentally erased my 3k. I'll write that in. Okay, so let's go ahead and do the subtraction. Let's see, so 3k cubed minus 3k cubed, those cancel out, and they should, because that was our goal. Remember, we're trying to cancel them. And then we have 0k squared minus negative 6k squared. Those don't cancel. Instead we have, because of the double negative, positive 6k squared. And remember, we have the cycle, so we'll bring down that plus 9k, and we have a new binomial. So now my question is, how many times, or what do I multiply k by to get 6k squared? Let's see, I can multiply it by plus 6k, because 6k times k will give me that 6k squared. And once again, we don't really care about what that negative 2 is doing. It's just sort of a, I call it the sidekick. All right, so let's go ahead, plus 6k. We'll get ready to do the subtraction, so I'll set up for subtraction. And then we'll multiply the 6k to our binomial. So 6k times our binomial, that's going to be 6k squared minus 12k, because the 6k times the negative 2 is 12k. All right, and then what do we have? So doing the subtraction, the k squares cancel out, 6k squared minus 6k squared. Once again, that's our goal, so that should happen. And then we have the 9k minus the negative 12k. So that's going to be 9k minus the negative 12, which means it'll be 9k plus 12k. So that'll be 21k. All right. And we're not done yet. We still need to bring down that negative 14 for the last cycle. It's the last item to bring down. And then, oh, we're almost done. Okay, so bringing down that negative 14. Please remember the signs. That's important. All right, setting up for subtraction. What's the question now? The question is, what do I multiply k by to get positive 21k? Well, k, I'll go ahead and multiply it by 21k. So 21, ooh, I'm not going to multiply it by 21k. I'll just multiply it by 21, because 21 times k will give me that 21k. All right, good. So we figured out it's 21. Then we'll do 21k times, and multiplying it by the negative 2. 21 times 2, that's going to be 42. So negative 42. All right, let's see. Let's go ahead and do the subtractions. So 21k minus 21k, those two are going to cancel, which it should happen because that's what we're aiming for. And then we have the negative 14 minus 42. So negative 14 minus negative 42. That'd be negative 14 plus 42. And what would that be? So let's see. We have the 42 minus 14. Borrow 3. 4. And that's going to be 8 and 2. So 28. So my answer is going to be 28. All right, that's my remainder. Okay, so for my final answer, what do we do with the remainder? Well, we're going to go ahead and write down the quotient we have right up on the top, the 3k squared plus 6k plus 21. Sorry, waiting for my pen. Okay, there we go. So we'll write that down, but then we have that remainder. So what do we do with the remainder? We'll go ahead and do plus. We'll write our remainder, 28, and then divide it by our divisor, which is k minus 2. And that's what we do with the remainders. All right, and that is it for the division of polynomials doing the longhand.